Today I want to solve problem number 4 under moment distribution method, and this is frame. So the question reads, analyze the frame shown below and hence draw bending moment diagram indicating all values at critical points. So this is the frame. As you can see, the frame is fixed at point A. Again, it is fixed at point D, fixed at point E, and it carries a both UDL, which is uniform distributed load, and a point load. So a point load of 20 kilonewton placed at 2 meters from point B and 2 meters from point A. A UDL of 30 kilonewton per meter spanning at 8 meters. A point load of 40 kilonewton placed at 2 meters from E and 3 meters at B. Again, 30 kilonewton placed at 3 meters from E and 3 meters from B. Again, it has I, 2I, 3I, and a 2I respectively. So let's see how you can solve such a question. So solution, we begin by fixed end moments. So we'll begin by this span. You can draw it here, or I can draw it here. So this is A, this is B, 20 kilonewton. This is 2 meters, 2 meters. So here we have MF BA, and here MF AB, like that. So during your exam, no need to draw such spans because it will take much of your time. So we start calculating our fixed end moment, MFAB. So MFAB is equal to minus WL over 8. So this one is equal to minus 20 times L, 2 plus 2 is 4, over 8. So this one is negative 10 kilonewton meter. We proceed to MF BA. So this one will be plus WL over 8. So it's equal to 20 times 4 over 8. So the other is plus 10 kilonewton meter. We proceed to BC. BC, we have this like that. So this is 30 kilonewton per meter. And the span is 8 meters. This is B, this is C. So MFCB, MFBC. So MFBC is equal to minus WL square over 12. So this is equal to minus 30 times L, which is 8 square over 12. So the answer is minus 160. Minus 160 kilonewton meter. MF CB is equal to plus WL square over 12. So this one will be plus 30 times 8 square over 12. So this one will be plus 160 kilonewton meter. We proceed to this sperm. So I can draw it here also. This is 40 kilonewton, 2 meters, 3 meters, C, B. So here, MF, BC, and here, MF, CD. So we start by MFCD. MFCD is equal to minus W A B square over L square. So this one will be minus 40 times A, which is 2, times B, 3 square over L, 3 plus 2, 5 square. So the answer is 28.8, negative 28.8 kilonewton meter. We proceed to MF, DC. So this one will be W plus W A square B over L square. So this one will be plus 40 times 2 square times 3 over 5 square. So the answer will be 19.2, positive 19.2 kilonewton meter. We proceed to CD. So CD, you can also draw it here like that. So this is 30. This is C. This is E. So from C to 30 is 3 meters, 3 meters. So here, MF, MFE, C, and here, MFCE. So MFCE is equal to minus WL over 8. So this one is equal to minus 30 times 6 over 8. So the answer will be minus 22.5. Minus 22.5 kilonewton meter. MF EC is equal to plus WL over 8. So this one will be 30 times 6 over 8. So the answer will be 22.5 kilonewton meter. So after having done so, we proceed to stiffness factors, which is K. So let's see how we're gonna do it. We proceed to stiffness factors. Stiffness factors, which is K. So you can see how structure is very easy. So many people fear structures, but it's very easy. Stiffness factors K. We start with joint B. Joint B. Joint B will have K1, and this is KB is equals to, you can see the farthest end is fixed. So if the farthest end is fixed, the formula is I over L. I over L. So I here is 1, and L is 2 plus 2, which is 4. So 1 over 4. So again, KBC, K, which is K2, KBC. KBC, you can see the farthest end is continuous. So it means the formula is I over L. So this one will be I is 2 and L is 8. So this one is 1 over 4. Like that. We proceed to joint C. Joint C. Joint C like that. So we have K3. K3 is KCB. KCB. So the farthest end again is continuous. So I over L. The I is 2 and L is 8. So 1 over 4. That is KCB. K4. K4 is KCD. KCD. So the farthest end is fixed. So the formula is I over L. So the I is 3. The I is 3. And the L, 2 plus 3, 5. So like that. We have K5, which is KCE. So this one is, the farthest end is fixed, so the formula remains I over L. So the I is 2 and L is 6. So 1 over 3. And this one is 3 over 5. We proceed to joint I think you are done. We can now start calculating our distribution factors. So let's see how we're going to calculate our distribution factors, which is DF. Distribution factors. DF. So we start by joint A. So joint A, we have DFAB. DFAB. So DF B is equal to 0 because it is fixed. We go to joint B. Joint B will have DF. So DF, BA. So DF, BA will be K1 over K1 plus K2. So this one is called K1 is 1 over 4 over 1 over 4 plus 1 over 4. So the answer is 1 over 4, 1 over 4 plus 1 over 4. So the answer is 0.5 or a half, like that. We proceed to DF, BC. DF, BC. So this one will be K2 over K1 plus over K2 plus K1. So K2 is 1 over 4 over 1 over 4 plus 1 over 4. It remains the same, 0.5. So if you want to know if you are correct, the distribution factor of a joint should be added up to 1. So 0.5 plus 0.5 is equal to 1. So our answer is very correct. We move to joint C. Joint C. For joint C, we have the FCB. So the FCB will be K3 over K3 plus CD K4 plus CE K5, like that. So K3 is a quarter over a quarter plus K4, 3 over 5, plus K5, a third. So the answer is, you can punch your calculator. So the answer is 15 over 71. Like that. We proceed to DF. DFCD. So DFCD will be K4 over K4 plus K3 plus K5. So this one will be K4 is 3 over 5 over 3 over 5 plus K3 a quarter plus a third. So this one should give you, punch your calculator again. That's 6 over 71. The last one, DFCE. So this one will be K5 over K5 plus K3 plus K4. So this one is equal to K5 is a third over a third plus 1 over 4 plus 3 over 5. So the answer should be 20 over 71. So we can check if our distribution factor are correct by adding all of this, and the answer should be equal to 1. Yes, the answer is equal to 1. So it means we are very correct. We proceed to joint D. So joint D, DC will be 0. So DC will be 0. And joint E, EC will be 0. Because they are fixed. So we proceed to table. This is our table. And this is what we have calculated. So I have captured everything we have calculated here so that you can take it from here and put it in the table. And this is our frame. So I want to explain this. So in this table, you have joint. So under joint, we have joint A, and we have member also. So joint A has member AB, joint B, member BA, BC, yes, and joint C, CB member, CB, CD, and CE. Joint D, we have DC, only one member, and joint E, we have member EC. We have distribution factors for various members. They are here. So AB is 0, as you can see. BA is 0.5, it is here. And also BC is 0.5. CB, 15 over 71 is here. CD, 36 over 71 is here. CE, 20 over 71. Again, we have fixed end moment. We already calculated this. AB, negative 10. BA, positive 10. BC, negative 160. CB, positive 160. Like that, up to the last one. So what follows next? There is no joint to release here. So we will go direct to balance. So balance. So we are going to balance joint B and joint C. Why are we balancing joint B and C? Because as you can see, this joint, it has 2 members, and this one has 3 members. So for this joint to be in balance, it means the fixed end moment of each member, the sum of these moments should be equal to 0. If not equal to 0, it means this joint is not in balance. The same to this case. This plus this should give you 0. If not equal to 0, it means the joint, which is C, is not in balance. So we start with B. Balance B. So we have 10. You take 10 plus negative 160. As you can see on my calculator. So the answer is negative 150. It means joint B is not in balance. So how do you balance it? You'll take positive 150 and distribute to each member by multiplying with its distribution factors. So we change the sign to positive and the value remains the same. So positive 150 times 0.5. We are now distributing. So here is 75. Again, positive 150 times 0.5, it is 75. Like that. So we go to C. C, we have 160 plus minus 28.8 plus minus 22.5. So the answer is not equal to 0, as you can see on my calculator. So the answer is positive 108.7. So you will change the sign of that answer, which is positive, to negative. So we will take negative 108.7 and distribute equally to each of these members. So negative 108, negative 108.7 times this one, 15 over 71. So the answer is negative 32.61 over 142. We proceed to this one. We take negative 108.7 times 36 over 71. So the answer is 19, negative 19, 566 over 355. That is negative, like that. I want to show you. We proceed to this. We take negative 108.7 times 20 over 71. So the answer is negative 21.74 over 71. Like that. So after every balancing, what follows next is carrying over. So carry over. So we carry over a half of this member we have balanced to opposite member. So we'll carry a half of this to the opposite member, BA, which is AB. So this one will be that 5. Again, BC to CD, half of this, that 5. A half of this will be negative 32.61 divided by 142 times 0.5. So a half of this is negative 32.61 over 284. Again, a half of CD to DC, half of this to this member. So 19,566 over 355 divided by 2. So here you have negative 9783 over 355. Again, a half of CE to this. So this is a half, a half, a half, a half, a half, like that. So 2174 over 71. So it's negative 1087 over 71. After that, we balance again. Balance until you get a very small value. That is why you will stop. So we balance this one, B, by taking this value. We will take positive 3261 over 284 and distribute equally to each of these. So we begin positive 3261 over 284 times 0.5. I want to show you. That's 261. So here is 32. That's 2. 61 over 5, 68. It will be the same to this. After every carrying over, what follows next is balancing. Now we will balance using these values here. So at B, you have negative 3261 over 284. You change the sign from negative to positive. So it will be positive 3261 over 284 and multiply it by distribution factors of each member. So you'll take positive 3261 over 284, multiply by 0.5, you will get 3261 over 568. Again, positive 3261 over 284, multiply by 0.5, you will get 3261 over 568. We proceed to joint C. It has positive 35. So you will change this positive to negative. So it will be negative 35. So negative 35 multiplied by each of this distribution factor for every member, negative 32, 35 times 15 over 71, we'll get that answer. Maybe I can show you on my calculator. Negative 35 times 15 over 71. So that is 525 over 71. Like that. Again, you take negative 35 times this, you will get that answer. Again, negative 35 times the last distribution factor, you will get that answer. And then after every balancing, the next step is to carry over. So you will carry over a half of these values you have balanced to the next opposite joint. For example, we have joint BA, which has 3261 over 568. So the opposite of BA is AB, a half of this to this joint, like that. BC, the opposite of BC is CB. Half of this value to the opposite joint. So this is the value. Again, half of CB, this value to the opposite member, which is BC, like that. Maybe I show you on my calculator. 5 negative 525 negative 525 over 71, and then you divide by 2. So you get negative 525 over 142. This value. Again, we come to CD. A half of this value to the opposite member, which is member DC. So it will be negative 630 over 71. Again, a half of this CE to the opposite member, which is EC. So you will continue with the process until you get the lower value. So that is where you can end and find your or calculate your final moment. So we proceed. After carrying over, we balance. So balancing, we come to this value. You take the opposite side of negative, which is positive, and then the value remains the same. So it will be positive 525 over 142 times 0.5. Again, you repeat the same times 0.5. And then the value, the answer you insert in that box. So 525 over 142 times 0.5. So the answer is 525 over 24. Again, the answer will remain the same because the DF are the same. are the same. So we proceed to joint C. At joint C, we have this value. As you can see, it is positive 3261 over 1136. So you change that positive to negative, and the value remains the same. So you take negative 3261 over 1136 times each of these distribution factors. This and this and that. So it will be negative 3261 over 1136 times 15 over 71. Again, you repeat the same. Negative 3261 over 1136 times this. Again, negative 3261 over 1136 times this. And then you're under, you put it in that box. After every balancing, you carry over a half of this to the opposite member, as you can see, a half of this to the opposite member, a half of this to the opposite member, a half of this to the opposite member, again a half of this to the opposite member. After that, we balance again. So balancing B, you'll change this sign from negative 0.3043 to positive 0.3043 times each of these distribution factors. So positive 0.3043 times this, again positive 0.3043 times this. These are your values. Again, you come to this one, you have positive 525 over 568. So you will change that sign from positive to negative and distribute it equally to each of that member, CB, CD, and CE. So we have positive 525 over 568 to change it to negative 525 over 568 like this. Again, negative 5, 25 over 5, 68 like this. Again, negative 5, 25 over 5, 68 like this. So these are your results respectively. Again, you will carry over after every balancing step. So a half of this to the opposite member, 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 a half of this to the opposite member. So after reaching this value, you can see this is the smallest value, 0.07, 0.09, 0.07, like that. Now you can calculate your final moment. So your final moment is the total sum from fixed end moment as you go downward until your last carryover. That is your final moment. So we will start with member AB, negative 10. Negative 10 plus 35 plus this plus this plus this. You'll get 28.9. If we come to BA, positive 10 plus this plus this plus this plus this, you'll get 92.7. You will repeat up to the last member, which is EC. So until you get that value. So these are our final moments. You can check your final moments if they are correct or not. So for a joint to be in balance, the member of that joint, the fixed end moment, their final moment should be add up to 0. For example, joint B, you can see positive 92.7 plus minus 92.7 is equal to 0. So it means our final moment are correct. We come to C. C, this value, you add to this, it should give you 0. If not 0, then it means you have made an error in your calculation. So let's prove these values. 167.7 minus 103.6 minus 64.1. So the answer is equal to 0. So it means our calculation are very correct. You can check on my calculator. So after this, what follows next is to draw bending moment diagram. And before you draw bending moment diagram, it is very important to calculate the free span moments. So if the question did not tell you to come up with a shear force diagram, then there is no need to calculate reactions because it will take much of your time. So go direct to free span moments and draw free span moment diagrams, and then you draw your bending moment diagram. So let me show you. Free span moments. So we begin with span AB. So span AB, the formula will be WL over 4. So the W is 20 and the L is 4 and over 4. So the answer is 20 kilonewton meter. We have span BC. Span BC, the formula is WL square over 12 over 8. So this one will be 30 times 3 from here to here is, no, from here to here is 8. times 8 square over 8. So the answer is 240 kilonewton meter. We proceed to span CD. Span CD, the formula is WAB over L. So the W is 40 times A is 2, B is 3, L is 5. So the answer is 48 kilonewton meter. Span CE, the formula is W L over 4. So the W is 30, the L is 6 over 4. So the answer is 45. This is our final moment, bending moment diagram, and it is a combination of free span moments. We have calculated this and also our final moment from the table. So I will explain in detail. I will begin by free span moment. For span AB, as we calculated earlier, our free span moment for AB was or is 20 kilonewton meter. So this is for span AB. We proceed to span BC. Span BC, it is loaded with a UDM, so it will curve. So 240, approximate from here to 40 like that. We proceed to CD. CD is here, that is 48. So 48 like that. We proceed to CE. CE, foot 5, this one, foot 5. And then you come to this one, AB. AB is 28, this one, 28 here. And then we have BA. BA is 92, 92 here. Then you go to BC. BC is negative 92 here. You go to CB. CB along this line, 168. You go to CD, 103. CD along this line, yeah. And we go to DE. DE. DE is negative 18.2. Approximate like there. And then we have CEEC, 1.72 from here to here. 1.72. And our question ends there. And for those who have not subscribed to my channel, kindly subscribe